Dawn, late dry season. Southern African savanna. The light arrives slowly, pale and low, spreading across open grassland broken by scattered acacia and termite mounds. Night cool still lingers in the air. A faint wind moves through brittle stems, carrying dust and the distant calls of francolins waking to morning. Silence dominates, not empty, but alert. On a dead branch above the plain, an eagle waits. Its body is motionless, feathers drawn tight against the chill. Only the head moves, scanning the ground below with deliberate precision, vision tuned for detail, distance measured without haste. Below, near the base of a sun-warmed rock, a cobra emerges. Its scales catch the early light, muted browns and grays blending into soil and stone. The snake advances cautiously, tongue testing the air, muscles working in quiet coordination. This is not a hunt, nor a display. Only routine movement through contested ground. Neither animal acknowledges the other yet, but their paths are converging. In this landscape, encounters are rarely announced. When they come, they unfold in seconds. And here, between sky and earth, one movement will be enough to decide which life continues into the morning. Across sub-Saharan Africa, large raptors and venomous snakes have coexisted for millions of years, shaped by the same selective pressures of heat, scarcity, and competition. The eagle above the plain belongs to a lineage refined for aerial dominance. In southern Africa, species such as the martial eagle, Polometus bellicosus, occupy the upper tier of the avian food web. With wings spanning more than 2 meters and talons capable of exerting immense force, it is among the continent's most powerful birds of prey. Its anatomy reflects this role. Dense bone structure, reinforced leg muscles, and eyes adapted to resolve small movements at extreme distances. The cobra below represents an equally ancient evolutionary solution. Species like the Cape cobra, Naja nivea, are highly venomous elapids, adapted for speed, precision, and chemical defense. Their venom is primarily neurotoxic, disrupting nerve transmission and causing respiratory failure in prey or attackers. Unlike constrictors, cobras rely on a single accurate strike, delivering venom through hollow fangs connected to specialized glands. This strategy allows them to subdue animals larger than themselves while minimizing physical struggle. Both animals occupy overlapping habitats, open savannas, semi-arid plains, and scrubland, where visibility is high and cover is limited. These environments favor keen vision, rapid reaction times, and efficient energy use. For eagles, thermal updrafts reduce the cost of flight. For cobras, basking sites regulate body temperature, enabling bursts of speed when required. Each depends on precise timing rather than prolonged exertion. From an evolutionary perspective, their encounter is not unusual. Studies of raptor diets across Africa show that snakes can make up a significant portion of prey items, particularly during dry seasons when mammals are scarce. Martial eagles, tawny eagles, and brown snake eagles have all been documented hunting venomous snakes, including cobras. Conversely, venom evolved not specifically for predators like eagles, but as a broad defensive and predatory adaptation in an ecosystem filled with threats. The cobra's sensory world differs sharply from that of the bird above. It does not rely on sharp vision, but on chemical cues and vibration. The tongue, flicking rhythmically, gathers airborne particles and delivers them to the Jacobson's organ, allowing the snake to detect prey, rivals, or danger. Ground vibrations, subtle shifts caused by footsteps or wing beats, are transmitted to the soil and sensed through the body. This provides early warning, though it lacks directional clarity. The eagle's advantage lies in anticipation. Raptors possess binocular vision that allows depth perception critical for timing a strike. Research on avian predation indicates that large eagles calculate approach angles and speed well before committing. A failed strike is costly. Energy loss cannot always be recovered quickly in harsh environments. As a result, eagles often observe for extended periods, waiting for a moment when prey movement exposes vulnerability. Ecologically, both animals serve stabilizing roles. Eagles regulate populations of small mammals, reptiles, and birds, preventing overgrazing and disease spread. Cobras control rodent numbers and other small vertebrates, influencing seed dispersal and vegetation dynamics indirectly. Neither is dominant by virtue of morality or intent. They persist because their strategies work often enough. Environmental pressures intensify these interactions. During dry seasons, prey density drops. Water sources shrink. Animals are forced into closer proximity, increasing the likelihood of encounters between species that might otherwise avoid one another. Documented field observations show higher rates of raptor, snake confrontations during these periods, particularly near rocky outcrops and termite mounds that provide shared resources. In this setting, risk is mutual. A cobra's venom is lethal, but only if delivered accurately. An eagle's talons and beak can kill instantly, but only if contact is made without hesitation. Evolution has not favored caution alone, but commitment, decisive action within a narrow margin of error. The relationship between raptors and venomous snakes has been examined through decades of field observation, necropsy analysis, and behavioral study. In many cases, snake remains found beneath eagle nests confirm successful predation. Yet scars, missing talons, and recorded fatalities also attest to the cost of miscalculation. These encounters are among the most balanced predator-prey interactions in the African savanna, where neither participant holds absolute advantage. Eagles that hunt snakes exhibit specialized behaviors. Research on brown snake eagles, Cercidas cinereus, and martial eagles shows a preference for attacking the head region, neutralizing the venom delivery system as quickly as possible. The talons, curved and reinforced, are driven down with focused force, pinning the skull or neck against the ground. The beak follows, delivering crushing bites to the cervical spine. This sequence is not instinctive improvisation, but a pattern refined through natural selection and, in some species, learned experience. Juvenile eagles, lacking precision, face higher mortality when attempting such prey. Studies tracking raptor survival rates indicate that inexperienced birds often abandon snake prey after initial contact, having learned the danger through near misses. Adults, by contrast, display more calculated restraint, waiting for moments when a snake is extended in motion rather than coiled in defense. This reduces the range of a retaliatory strike. Cobras, for their part, are not passive. Their iconic hood display serves multiple functions. It exaggerates body size, deters predators, and stabilizes the neck for rapid forward strikes. High-speed video analysis of cobra strikes shows that they can deliver venom in less than 1/10 of a second, with accuracy sufficient to target eyes or facial tissue. Against mammalian predators, this often proves effective. Against aerial predators, the outcome is less certain. Venom expenditure is costly. Cobras do not strike indiscriminately. Venom takes time and energy to replenish. Defensive strikes may be dry, without venom, or only partially envenomating. Field observation suggests that cobras facing large birds may prioritize evasion over repeated strikes, especially if escape routes exist. However, when pinned or surprised, the response becomes immediate and uncompromising. Physiologically, both animals are constrained by temperature. As ectotherms, cobras depend on ambient warmth to maximize muscle speed and coordination. Early mornings can reduce strike velocity. Eagles, endothermic and insulated, remain fully operational at lower temperatures. This temporal mismatch creates predictable windows of vulnerability. Studies in semi-arid regions show that snake predation by birds peaks during early morning hours before ground temperatures rise. The terrain itself influences outcomes. Open ground favors the eagle, limiting concealment and escape. Rocky substrates and dense grass increase the cobra's chances by breaking sight lines and absorbing impact. Termite mounds and fallen logs often become focal points for these interactions, offering both basking surfaces and elevated perches. Despite the apparent violence of such encounters, they are statistically rare relative to the daily movements of both species. Most eagles will pass over countless snakes without engaging. Most cobras will never face an aerial predator directly when they do meet. It is not because one seeks the other, but because ecological necessity compresses their worlds into the same narrow space. In these moments, biology dictates behavior. There is no hesitation rooted in fear, no aggression born of intent. Only the execution of strategies shaped by millions of years of survival in the same unforgiving landscape. From the perspective of survival biology, this encounter is defined by constraints rather than choice. The eagle's body is engineered for decisive force delivered from above. Its skeletal structure absorbs impact, while tendon-locking mechanisms in the feet allow talons to remain clenched without continuous muscular effort. This enables a rapid strike followed by sustained restraint, critical when subduing prey capable of counterattack. The moment the eagle commits, retreat becomes difficult. Success depends on precision rather than strength alone. For the cobra, survival hinges on reaction time and spatial awareness. Its elongated body allows sudden directional change, but only within the limits of muscle temperature and ground traction. When threatened from above, the snake's visual field offers limited warning. Unlike mammalian predators, birds produce minimal ground vibration before contact. This asymmetry places a cobra at a sensory disadvantage, particularly in open terrain where overhead cover is absent. Viewed through the lens of hunting strategy, the eagle does not rush. Observational studies describe prolonged surveillance periods lasting several minutes, during which the bird adjusts its position relative to wind and light. Approaches are typically downwind and angled to minimize shadow movement across the ground. This reduces the chance of detection. Only when a snake is fully extended, crossing open ground or transitioning between shelter, does the eagle descend. The cobra's defensive strategy relies on escalation. Initial responses may include freezing or slow withdrawal. If the threat closes, the hood spreads, body lifts, and strike range increases. This display is metabolically inexpensive but visually conspicuous. Against terrestrial predators, it often suffices. Against an eagle, it can have the opposite effect, confirming the snake's position and orientation. Instinct and learning intersect sharply in such encounters. Eagles that survive early interactions with venomous snakes refine their technique over time. Research on raptor cognition suggests memory of dangerous prey influences future decisions, shaping both prey selection and attack angle. This is not intelligence in the human sense, but adaptive learning reinforced by survival outcomes. From the cobra's perspective, there is no equivalent learning opportunity. Most encounters end immediately, one way or the other. Evolution compensates through redundancy. Speed, venom potency, and deterrent display ensure that enough individuals survive across generations. The system does not protect the individual. It protects the lineage. A final angle lies in moral neutrality. Neither animal acts with intent to dominate or destroy. The eagle does not hunt out of aggression, nor does the cobra defend out of malice. Both respond to pressure, hunger, exposure, proximity. In this balance, there is no fairness, only effectiveness. Nature does not reward effort. It rewards outcomes. Another angle emerges through the lens of sensory limitation. The eagle's vision is acute but narrow. Focus on the ground. It sacrifices awareness of lateral threats. A misjudged strike exposes eyes and face to venom, injuries that have been documented in recovered raptors. Some survive with partial blindness. Others do not. Risk is not theoretical. It is immediate and physical, etched into scar tissue and missing feathers. For the cobra, the absence of sound works against it. The eagle's descent produces little auditory warning until the final moment. Field recordings show that many snakes do not initiate defensive postures until a raptor is already within striking distance. This delay reduces the effectiveness of venom delivery, forcing the snake into a reaction rather than a deterrent role. Social structure also influences outcomes. Eagles are solitary hunters, relying entirely on individual competence. There is no cooperative defense or shared knowledge. Each confrontation is an isolated test of ability. Failure does not educate the population. It removes the individual from it. Cobras, likewise, operate alone. Their interactions with predators do not involve group warning or collective resistance. Isolation sharpens the stakes. Parental investment adds another layer. Adult eagles with active nests show increased risk tolerance. Studies have documented higher prey diversity, including dangerous prey, during chick-rearing periods. Energy demands rise sharply, pushing adults to exploit resources they might otherwise ignore. This increases encounters with venomous snakes near nesting territories, especially where prey density is low. From the cobra's side, reproductive cycles affect behavior. During breeding seasons, males range more widely, increasing exposure. Gravid females, heavier and slower, are less capable of rapid escape. Observations indicate that predation risk rises during these periods, not because behavior changes dramatically, but because physical limitations accumulate. A final perspective lies in ecological consequence. When eagles remove large venomous snakes from an area, rodent populations may increase temporarily, altering vegetation pressure. When cobras persist, they regulate small mammal numbers more directly. Neither outcome is inherently beneficial or harmful. Ecosystems absorb these shifts, rebalancing through feedback loops measured not in days, but in seasons and years. These angles converge on a single truth. Encounters between apex predators are not spectacles of dominance. They are narrow intersections of biology, timing, and terrain. Each participant arrives with advantages and vulnerabilities. The outcome is decided not by reputation, but by the alignment of variables in a moment that allows no correction. Morning advances, but the sun has not yet lifted the ground to full warmth. The air remains cool enough to slow muscle response at ground level. From its perch, the eagle adjusts its stance, turning slightly into the wind. Feathers along the legs tighten. The head lowers, eyes fixed. Below, the cobra moves from shadow into open light. Its body stretches fully now, crossing a narrow strip of exposed soil between rock and grass. The tongue flicks, sampling air that carries no warning. The snake's posture is neutral, neither hunting nor defending. In this instant, it is most vulnerable. The eagle commits. Wings fold partially, not fully closed, controlling descent rather than speed alone. Gravity does the work. The approach is angled, not vertical, minimizing silhouette and shadow. At the last moment, the legs extend forward, talons opening in precise alignment. This is the most dangerous phase. If the strike lands too far back, the cobra's head remains free. If it lands too shallow, momentum carries the bird past its target. Impact. Dust lifts from the ground. The eagle's talons pin the cobra just behind the head, pressing neck and upper body into the soil. The force is immense, concentrated through curved claws designed to pierce and hold. The snake reacts instantly. The hood flares, but asymmetrically, constrained by pressure. The head twists upward, fangs flashing toward the eagle's face. This is a margin where survival narrows to centimeters. The eagle shifts weight backward, pulling the snake's head away from its body while maintaining downward pressure. The wings flare briefly to stabilize balance. The cobra strikes once, then again, fast, controlled movements powered by muscle that is not yet fully warmed. One fawn grazes feathers. Venom is expelled, but it disperses harmlessly across plumage. The eagle responds without pause. The beak comes down hard at the base of the skull. Bone yields. The cervical vertebrae compress under focused force. Neural signals to the body fracture into disorder. The cobra's movements slow, then become uncoordinated, muscle contractions without direction. But the danger does not end immediately. Even incapacitated, a cobra can deliver reflexive bites. The eagle maintains distance, holding the snake at arm's length, adjusting grip to keep the head immobilized. Only after several seconds, longer than it appears, does the resistance fade. Breathing steadies. The wings fold. The encounter ends as abruptly as it began. There is no display of victory, no pause for assessment. The eagle lifts off its prey, laboring briefly under the added weight, before catching a rising thermal. Below, disturbed dust settles back onto the plain. The rock returns to silence. This sequence, documented in high-speed field footage and post-event analysis, rarely lasts more than 15 seconds. Yet within it exists the full measure of risk. Had the timing shifted, had the cobra been warmer, more coiled, more aware, the outcome could have reversed entirely. Eagles have been found dead near snake carcasses, victims of a single successful strike delivered too close to the eye or beak. Here, variables aligned. The strike decided life and death, not through dominance, but through timing, temperature, and precision, forces indifferent to which body lay above or below. The aftermath of the strike unfolds not in violence, but in control. As the eagle gains altitude, it adjusts its grip repeatedly, ensuring the cobra's head remains fixed and distant. This behavior has been documented across multiple raptor species that hunt snakes. It reduces the risk of delayed envenomation, a danger that persists even after fatal trauma. Venom glands can discharge reflexively, Fangs can still penetrate soft tissue. Distance is survival. The ascent is deliberate. Heavy prey alters flight dynamics, forcing the eagle to seek rising air rather than power alone. Thermal columns, created as the sun warms the uneven ground, provide lift with minimal energy cost. Within minutes, the bird reaches a height where the landscape flattens into patterns of light and shadow. On the ground, the cobra's role ends. Its body, once a precise instrument of movement and chemical defense, becomes part of another process. If dropped, it will feed scavengers and insects. If carried to a nest, it will be dismembered and distributed to growing chicks. In either case, its energy transfers upward the food web, sustaining life beyond itself. Such climactic encounters shape behavior over time. Eagles that succeed reinforce effective techniques. Those that fail do not persist or refine them. This is not learning in a cultural sense, but filtering. Traits and responses passing forward only if they work under pressure. Similarly, cobra populations persist not because individuals survive predation, but because enough do to maintain continuity. Field data suggests that most snake-eating raptors do not specialize exclusively in venomous prey. The risk is too high. Instead, these hunts occur opportunistically when environmental conditions tip the balance. Early morning, cooler ground, exposed to rain. The climax is not random. It is conditional. There is also absence in this moment. No observers intervene. No warning calls follow. The savanna absorbs the event without trace. Grass springs back. Wind erases disturbance. What occurred leaves no visible mark on the land, only a shift in probability. One less cobra here. One eagle momentarily sustained. In long-term ecological terms, this single outcome matters little. Populations fluctuate within tolerances shaped by climate, disease, and human influence far beyond this clearing. Yet for the two bodies involved, the stakes were absolute. One life ended without ceremony. The other continues, briefly advantaged by calories gained and risk survived. The climax does not resolve conflict. It resets equilibrium. The consequences of such encounters extend beyond the immediate exchange of force. For the eagle, survival does not end with a successful kill. Physical toll accumulates subtly. Microscopic damage to talons, stress on wing joints during heavy lift, and exposure to venom residue all contribute to long-term wear. Longitudinal studies of large raptors reveal that individuals engaged in high-risk prey capture often show reduced lifespan compared to those relying on smaller, less dangerous prey. Survival here is not free. It is purchased incrementally. If the cobra is delivered to a nest, its value multiplies. High-protein prey supports rapid chick growth, strengthening immune systems and accelerating feather development. Nest cameras have recorded chicks feeding on snake prey over several days, each portion sustaining growth during periods of scarcity. Yet this benefit comes with delayed cost. Adults that hunt dangerous prey more frequently exhibit higher injury rates, increasing the chance of nest failure later in the season. For the cobra population, loss is diffuse rather than immediate. Individual mortality does not destabilize numbers unless pressure is sustained. Reproductive strategies compensate. Cobras produce multiple offspring, many of which will never reach maturity due to predation, climate stress, or starvation. This is not inefficiency. It is adaptation to high-risk environments. Predation by birds is one of many filters shaping survival. Behaviorally, surviving cobras do not alter strategy in response to predation in a way humans might recognize. There is no collective memory, no generational transmission of avoidance. Instead, spatial patterns shift subtly. Areas with higher raptor density may see reduced snake activity during early mornings, not through learning, but through statistical removal of individuals most exposed at those times. Over seasons, this alters encounter frequency without conscious adjustment. At the ecosystem level, these interactions ripple outward. Reduction in large snake numbers can temporarily increase rodent activity, affecting seed predation and plant regeneration. In turn, this may influence insect populations and soil composition. However, such effects are often localized and transient. African savannas are resilient systems, shaped by variability rather than stability. They absorb loss and redistribute pressure. Documented studies emphasize that predator interactions, while dramatic, contribute less to population control than disease, drought, and habitat change. Yet they remain critical in maintaining behavioral diversity. The presence of risk shapes how species move, feed, and reproduce, even when encounters are rare. The aftermath, then, is not silence. It is adjustment, subtle shifts across bodies, behaviors, and landscapes that persist long after the moment of contact has passed. Over longer timescales, the effects of these encounters accumulate quietly. Eagles that survive repeated high-risk hunts often show selective restraint later in life. Tracking data indicates that older individuals diversify prey choices, reducing reliance on dangerous targets when alternatives exist. This is not wisdom in a human sense, but physiological pragmatism. Injury compromises flight, and compromised flight leads quickly to starvation. Longevity favors caution. In contrast, younger eagles face a narrowing window. Without experience or established territory, they must exploit available resources aggressively. Mortality rates among subadult raptors are highest during this phase, and venomous snakes account for a measurable portion of fatalities. Carcasses recovered near kill sites often show puncture wounds to the face or eyes, evidence of encounters where precision failed by fractions of a second. For cobra populations, the removal of larger, mature individuals can influence genetic distribution. Larger snakes are often more fecund, contributing disproportionately to reproduction. Predation pressure on these individuals may subtly favor earlier breeding at smaller sizes, a pattern observed in other reptile populations under sustained predation. These shifts occur over generations, not seasons, and remain difficult to detect without long-term data. The physical environment also records aftermath indirectly. Areas frequented by hunting eagles may accumulate fewer large snakes, changing the risk profile for other species. Small mammals adjust foraging patterns. Ground nesting birds alter nest placement. These responses are not conscious reactions to a single event, but emergent properties of repeated pressure. Importantly, the absence of a predator can be as influential as its presence. When an eagle removes a cobra from a territory, other snakes may expand into the vacated space. Competition replaces loss. This turnover maintains density while altering individual histories. No role remains unfilled for long. Scientific observations underscore a central pattern. Ecosystems do not preserve individuals. They preserve function. When one organism exits, another assumes its position, often invisibly. The savanna does not pause to register loss. It continues, recalibrating flows of energy and movement. From a human perspective, the aftermath may feel unresolved. There is no closure, no final accounting. But within ecological systems, this is resolution. Balance is not stillness. It is constant correction. Dusk settles over the savanna, softening edges of rock and grass into a muted palette. The eagle perches again, wings folded, talons resting. Its breath is steady, its gaze distant. The cobra's absence has left no mark on the wind, no echo across the plain. Life continues, indifferent to the struggle that unfolded, guided by forces older than memory. This encounter, a single strike, a single decision, reflect the economy of nature. There is no justice in hunt, no malice in defense. Each body acted according to design and circumstance, shaped by millions of years of evolution. Survival is measured not by effort, but by alignment. Speed, timing, and precision converging in a single, fleeting moment. Across the savanna, the same principles ripple quietly. Plants grow where herbivores graze. Predators hunt where prey ventures. Individual lives begin and end in cycles indifferent to recognition, yet essential to continuity. Every loss is compensated by persistence elsewhere, every risk offset by adaptation. The ecosystem endures, not through sentiment, but through relentless balance. The eagle's journey continues, each flight a negotiation with gravity, temperature, and opportunity. The cobra's lineage persists, guided by chemical perception and instinct, unaware of the moment that claimed one of its own. In these intersections, nature demonstrates neither cruelty nor kindness. It demonstrates inevitability. Here, life is neither heroic nor tragic. It is precise, efficient, and impartial. And in its quiet unfolding, there's a clarity that surpasses human understanding. A reminder that existence, in its rawest form, is a series of decisions dictated by circumstance, survival, and the indifferent measure of time.